What's up, students? It's me back again. I'm going to show you guys how to do solving exponential equations, this time for a base, not for the so we've got an equation here. There's a left side, there's a right side. The variable, though, is on the bottom. So how do we get that variable? Okay, there's going to be different situations and things like that, and this is I guess the last situation here. So let's talk about it. The goal here is to solve for an unknown base in exponential equations. Yeah, our steps are to solve an unknown base, substitute in any given values so the equation has only one variable, right? We know that because if you have just one equation and we've got two variables in it, it's good for nothing. You can isolate one of the variables as much as possible, but on the other side of the equation is going to be the other variable. So you're not going to be able to tell me what one variable actually is by solving it, right? You can only solve it if everything else is a number of some sort, and you can plug in all those numbers and work out what that unknown is. There can only be one unknown, right? Number 2 says isolate the unknown base on one side of the equation, and we do that by using reverse BEDMAS as always, right? And a base is isolated when its exponent is 1, right? And you gotta, that's the new little detail here. And if the exponent is not 1, we got to use the power rule and multiply it by the reciprocal of whatever it is so that we can turn it to 1. Okay? Use the power rule and multiply by the reciprocal exponent. Okay? On it, I guess we'll just say that. Let's cut off. Okay, so let's look at some examples here. I think some of you guys are going to look at a to the exponent 6 is equal to 729 and go, yeah, I'm just going to do the 6th root here, and that'll give me 729. And you know what? That's not necessarily wrong. But in terms of the steps here, I want to teach you the proper steps so that once you know these steps, you're going to execute those exact same steps for a simple one like this. And also for the complicated ones where there's multiple steps involved. You just do the same steps, you're going to be okay, right? So I know some of you guys are thinking, oh, I'm just going to 6th root this and 6th root this, and you can get the answer, okay? Or, you might look up on that power table that I gave you. This is definitely blurry, but what to the exponent 6 is going to be, what was that, 729, right? So what to the exponent 6? So you just kind of go down this line and go 1 to the exponent 6, 2 to the exponent 6, 3 to the exponent 6. What? 3 to the exponent 6 is 729, right? So you'll go, oh, that means a is equal to 3. Right? You could do it that way. But, how much communication is really going on here, except to say that you use a table to figure it out, okay? What I want you to do is use the steps. So the steps are isolating the base. In this case, the base is isolated. The second step is to multiply that exponent on the base by the reciprocal. So if you think about the number 6, the reciprocal of number 6 is 1 over 6, okay? Because I know if I multiplied these two, the 6 times 1 over 6, I'm going to get 1. And a reciprocal is what you need to multiply something by to get the answer, positive 1, okay? So in this case, I'm going to multiply both sides, check it out, by 1 over 6. Okay, I'm going to come in with 1 over 6 is equal to, this would be 729, and this is my communication here. I'm going to multiply both sides. I'm going to raise both sides to the exponent 1 over 6. What happens on the left side here is this is 6 times 1 over 6, which we already discussed, which is equal to 1. So there you go. That's a to the exponent 1 now, right? And over here, I get 729 to the exponent 1 over 6. And you can do this on your calculators, right? You punch in 729, and you hit this button. If you've got a Casio like me, you're going to hit a button that looks like this. I guess I'll draw it right here. You're going to hit a button that looks like this, X. And there's a block there, okay? And that allows you to punch in the base, whatever the X is, and this time we're going to hit 729. And then for this button, we're going to hit 729, and then I'm going to hit this button. You might actually have another button that actually looks like this. Here, let me just lay that out, okay? Same thing, same function. Again, you punch in 729, and up here for the exponent, after you press this button, you're going to type in 1 divided by 6, okay, in brackets. Or you can also punch in, if you've got this fraction button, okay, if you got a fraction button, you're going to punch in 1 over 6 as well, okay? And so you can do either one, but make sure you get the order right, and make sure you get the calculator to understand that you are trying to do 1 divided by 6, okay, in brackets. That's very, very important. And if you do that, you get 729 to the exponent 1 divided by 6, close the bracket around that, hit equals, yep, and you'll get 3. Just want to double check and make sure I got it right. Yep, A is equal to 3. And there's your answer, right? A is equal to 3. And we're just going to use this step and do all this other business too, okay? So let me just take this and move it up. Good. Where was it? That was a part of it. Okay, so let's talk about this one over here. This is 5 to the b to the exponent negative 2. 5 times b to the exponent negative 2 is equal to 125. So let's do this with the proper steps. First thing is, we need to isolate that base on its own side. The problem is it's now being currently multiplied by 5. So let's get rid of that. Let's divide both sides by 5. Okay? And if we do that, this will turn into b to the exponent negative 2 is equal to 25. Next step. We got to identify the reciprocal to the exponent on the base. And the exponent on the base is negative 2. So if you write it along the side here, the exponent is negative 2. Then the reciprocal of negative 2 is 1 over negative 2. All right? So if we multiply both sides by 1 over negative 2, let's see what happens. Got the 25. We're going to put this to the exponent 1 over negative 2. You're going to see that, again, the left side here, this is negative 2 times 1 over negative 2, right? And if you multiply, this is negative 2 times 1, and the bottom it'd be 1 times negative 2. It'd be negative 2 divided by negative 2, which is positive 1, giving us the base on its own, which is what we want, because we want to know what that base is. On the right side, you go 25 to the exponent 1 divided by negative 2, or negative 1 over 2, okay? And punch that in. And you get, well, you can get a couple things, but on my calculator, I got 0.2, right? And that's it. Okay, that's how you do it. What's really going on here, if you want to figure it out, is this is 25 to the exponent negative 1 over 2. And remember, we talked about this stuff. We got to do it step by step. So let's handle the negative first. The negative causes the 25 to become 1 over 25, right? And we still got 1 over 2 left. And the 1 over 2 means square root the 1 and square root the 25. And if we square root the 1, this will stay as 1. And square root the 25, this will become 5. And 1 divided by 5 is 0.2. So hopefully that explains it. There's that answer. Let's keep it going. What about this? C to the exponent 3 over 2 is equal to 27. If you guys are following with the logic, trying to get that base isolated by multiplying by raising the exponent by the reciprocal of that exponent, then this is actually going to follow your logic, okay? So here we go. What? You know, if you look at that C, it's already isolated. It's on it. That base is by itself. That's fantastic. But the exponent on it is 3 over 2. So what is the reciprocal of 3 over 2? Well, somebody's going to say 3 over 2 times what will give you 1? The answer is 2 over 3. Right? Because 3 times 2 is 6, and 2 times 3 is 6. It would be 6 over 6, and that gives you 1, right? So we want 2 over 3. And that's exactly what we're going to do. So C to the exponent 3 over 2. And we are going to put that to the exponent 2 over 3, right? By the multiplication rule, right? And then here is the 27 still. And we're going to put this to 2 over 3. Okay, that's the reciprocal we're going to use. And in this case over here, on the left side, we know that we end up with c to the exponent 6 over 6, which is c to the exponent 1, which is what we want. And here we're going to go 27 to the exponent 2 over 3. And you can go, what's the cube root of 27 and then squared, or you can punch it into the calculator, 27 to the exponent 2 divided by 3. Close the bracket. Did you get 9? I think you did. Boom. There's our answer. Okay. That's if you punch it straight into the calculator. That's how to do it, right? Those are people who are like, well, I want to do it the old-fashioned way. Sure, if the numbers work out clean, that could be a reasonable thing to do as well, right? You're going to find the cube root of 27, then you're going to square it. The cube root of 27 is 3 times 3 times 3, so that is 3 squared, which is 9. Okay, that's another way to do it. What about this? 2 to the exponent d, 2 times d to the exponent 1 over 3, subtract 5 is equal to 1. There's a lot of business here. We want to get that variable d isolated by itself first. Okay, so we're going to get rid of the subtracting by 5, and then we're going to get rid of the multiplying by 2 in that order, because that's reverse bedmass. So let's send the subtract 5 over, and now we'll get 2d to the exponent 1 over 3 is equal to 1 plus 5, and 2d to the exponent 1 over 3 is equal to 6. Next up, we got to get rid of the multiplying by 2, because we're still trying to isolate the letter d. And we'll get d to the exponent 1 over 3 is equal to 6 divided by 2, happens to be 3. Okay, so what is the reciprocal of 1 over 3, right? So on the side, we can work that out. The reciprocal of 1 over 3 is actually 3 over 1, okay? Or simply 3. I'll write 3 over 1. Okay, because you multiply these, we're going to get 3 over 3, which is 1, right? And so the reciprocal is 3 over 1, so let's just fill that in. D to the exponent 1 over 3. And we're going to multiply this by 3 is equal to 3. And we're going to multiply this by 3. And these guys will cancel out, because 1 times 3 and 3 times 1 will give you just 1, which is the variable d by itself. And this is 3 to the exponent 3, which is not 9. It's 3 times 3 times 3, which is 27. Okay. All right. So, just solving the equations straightforward as a knowledge question, that's where we're getting to. And I want to spend a couple moments talking about some word problems too. All right. The volume of a ball can be calculated by v is equal to pi r to the exponent 3 over 4, where v is the volume and r is the radius. Find the radius if the volume is 7.692 centimeters cubed, and round your answer to 1 decimal place. Okay, so looking at it, we got a formula, right? And it's a formula because there's more than one variable there, and we just need to plug in and solve for whatever the variable is. In this case, what we're plugging in is that volume was 7.692. We need to plug it in. We need to substitute it in because, like I said in the beginning, you want to substitute in any other variable so that you can only work with the one variable. If you got two variables in play, it's no good. Okay, 7.692 needs to go in for the v, and let's do that first. So we're simply going to write 7.692 is equal to pi r 3 over 4. Okay, what about pi? Is that a variable? No. It is a symbol representing pi itself as a number, okay? And pi is a number that is not terminating. It is a decimal that continues on over and over. It does not repeat. It is just 3.141569, and it just goes on and on and on, okay? And some people even have competitions where they memorize pi, right? But for us, we will always just use the pi button from now on. Instead of 3.14, we're going to use the pi button. It's much more accurate, and we're going to sub it in and get our answers whenever we need to. Okay, so we're trying to isolate this letter r. So on this side, the first thing I would do is divide out pi on both sides, and that'll help me get towards getting the letter r by itself. Okay, so what this looks like now is 7.692 divided by pi is equal to r to the exponent 3 over 4. And let me write it over here. Okay, but we want r by itself. So what we need to do is we need to multiply both, we got to raise both sides by the exponent 4 over 3, right? Because the reciprocal of 3 over 4, the reciprocal is 4 over 3. It's the upside down version. If you multiply the tops and bottoms, you get 12 over 12 in this case, which is 1. That's what you want. Okay, so let's do that. Let's raise both sides by 4 over 3. Okay, that looks like this as a step to show all of your work. Notice I'm not dividing by pi because it will get messy. I'm going to save that till the end. And, you know, I won't have to round and stuff too. So let's raise this. Let's say exponent 4 over 3 is equal to r 3 over 4 raised to 4 over 3. Okay? So what happens here? Well, this will cancel out, right? 3 and the 3 will cancel out, 4 and 4 will cancel out. And on the right side, I have r. On the left side, you're going to punch this in. Do 7.692 divided by the pi button. Hit equals. And then take that answer and raise it to the exponent 4 over 3. Okay, did you get the answer? Which is 3.3. There we go, 3.3. 3.3 what? We're talking about a radius. This is the units there, centimeters cubed. So therefore, the radius is 3.3 centimeters. Okay, getting it? Hopefully you are. Let's talk about one more. It says the population of an island can be calculated by pt is equal to 3.32 t to the exponent 5.3. Okay, and pt represents the population in millions, and t is the time in years that pass by. So how many years would it take for the population to hit 45.67 million people? Okay, we're trying to get to 45.67 million people. So you're like, well, some of you guys are like, yeah, well, sir, you got three variables here. You got p, you got t, you got another t. Is that what's going on? No. Remember, pt is a function. It's like saying y. Okay, y. It's like saying, you know, y when the variable t is this. Okay, it's just a little bit of a describer in it. That's what the t is, okay? In this case, if I don't know what t is, or t is a variable, I'm going to say p bracket t. But if I know that t is 3, for instance, I'm going to write p bracket 3. But there is only one variable here. Like, that's what we call function, right? The function of x, right? So p, which is a function of t, okay? So I want you to think about pt as one variable. Not like there's two parts where eventually you have to divide out the t or divide out the p. It doesn't work like that, okay? Let's try it. Here we go. We're going to say p bracket t is equal to 3.32 times t to the exponent 5 over 3. Okay? We need to sub in something we need, right? 45.67. What is that? That is the future population, right? So pt at a certain time will be 45.67. So let's plug this in. If we plug it in, we are going to get 45.67 coming in for pt. And everything else will look like this. If you can draw threes properly, it'll be even better. What do we do next? That's right, we're going to divide out the 3.32 because we are trying to isolate that letter t on both sides. Okay, that's gone. And my left side actually indicates 45.67 divided by 3.32. I'm going to go ahead and do that first. Did you get 13.756021? Because I did. So let's write that in. 13 point, and we're going to try to be accurate. But, you know, 13.756 seems to be a pretty good number. Because the next one's 0, it's not going to change anything. So that's good. 13.756 is equal to t to the exponent 5 over 3. Next step, yep, we got to identify the reciprocal of 5 over 3. The reciprocal of that is 3 over 5, okay? If it's a negative, you keep the negative sign as well, because remember, the goal is to multiply this fraction and this fraction to get positive 1, okay? Very important to indicate. So we are going to use this 3 over 5 here. Oh, that was not a good. Here, I was looking for this. We're going to use this 3 over 5, and we're going to plug it in. Okay, so we got 13.756, and we're going to put this to the exponent 3 over 5. Because if we do that, we know that the right side will be t to the exponent 5 over 3 raised to the power of 3 over 5, which will cancel out. 5s will cross out, and the 3s will cross out. And I'm just going to get t by itself, which is what I want. And here I got 13.756 raised to the exponent 3 divided by 5, all in brackets. And I have a new number, which is 4.82. 4.82. What did I find out? Let's go back to the question. We are thinking about t. How many years will it take before we get 45.67 million people? Okay. The answer is 4.82 years. Okay. Therefore, it will take 4.82 years. That's how I'd write it. All right. I want you guys to try working on the practice sheet on 5.5 Rational Exponents Word Problems worksheet. It's a bunch of word problems. The answers are in the brackets. Fire me off an email if you have any questions. I'll try to get back to you as soon as I can. And that's all the lessons I have for you for this week. Please stay tuned, however, because we also have an assessment that I'll be posting for you guys to do. Take a picture, upload it all into one file, and send that to me so I can mark it and give you some comments on it. Okay, thanks very much, and hopefully you guys are all taking very good care of yourselves, and I'll talk to you soon. Bye.